My name is Andy Palmer. I work for Seagate. I am the Enterprise Sales Manager for the UK and Ireland. Enterprise is a class of product which is our highest performance, highest endurance range of products sold into data centers and enterprises. So Seagate is a storage device manufacturer. You know us for hard drives, basically. We are currently going through an evolution where you know us for devices, hard drives, SSDs. We're evolving into Seagate systems and Seagate live services as well. So our mission is to really simplify data storage. Let me talk about hard drives first of all, right? They are, what they are is a spinning platter of a glass substrate. On the surface of that platter are grooves, and they're concentric grooves, and they're very small. So if you think of an edge of a piece of paper, there's about 2,000 grooves in the space of an edge of a piece of paper. So they're on the surface of the platter. And then onto that we have a coating which consists of molecules. Think of it as very small grains of rice that we sprinkle into or splutter into those grooves. The read-write head then spins across it, and the read-write head is a magnet. And each of those grains of rice has two ends. One end is a north polarity, one end is a south polarity. They're magnetic. North and south. North, south, positive, negative, 1 and 0. 1 and 0 being binary code being compute language. So what happens is that this thing spins across, and it assigns a value to each of those grains of rice, and that's where the code gets laid down. So therefore, to grow capacity in a hard drive is quite easy. You either have to put more rice on the platter, get more grooves on the platter, or get more platters in the stack. So we've all heard of helium drives now, and helium is important because helium is a single molecule gas, whereas before it's just air drives, and air is a filthy gas full of different molecules and different sizes all buffered with each other. And as this thing spins at 7,200 RPM, the outside edge is spinning at around 70 miles an hour. And this read-write head it's not attached to the platter. It flies across it on the turbulence caused by the spinning thing. It's actually shaped like an aircraft wing. It's designed by aircraft engineers, so it has to float. And if it hits the platter, that platter's dead, right? So it has to really fly close to it and not touch it. So the engineering involved to have a spinning thing, that spinning flat, is phenomenal. And how close it flies, your fingernails have grown more in the last 6 seconds. That's how close it flies, right? So people say, wow, this is rocket science. We say, rocket science? All they do is blow things up. This is phenomenal engineering. So we use helium. We pump out all the gas, replace it with helium so we can get thinner platters with less turbulence, less drag, so we get more platters in the stack. That's one way, and that's happened. That's about 4 years ago. Next thing we do is we can overlay all those grooves across each other, which is called shingling. So you've heard of SMR drives. Shingle being the American word for roof tile, so it overlaps. And that has some constraints because you can read very easily, but writing's harder because you've got to unravel effectively the groove and then lay the data on and then let it go again. So that's about 30-40% capacity to the surface of the platter. You then have to grooves are so small that we're talking at the quantum level now, where the behavior of the molecules now starts to become irrational and unpredictable. So you've got to find a way, and if a 1 becomes a 0, that's dollars becoming yen. It's a whole different world then, isn't it, suddenly? So you have to work out a way of keeping it firm and fixed. So you have a different medium which holds that molecule a lot firmer. But of course then to flip it from a 1 to 0 when you want to requires more power. So you can't have that because everyone wants to cut their power of IT. And that's why we've changed the drive, the read-write head in some models to a laser and the near-field transducer and the plasma thing, because it heats the dot that it's about to read and write to make it more malleable. It can flip the molecule and it goes back to being rigid again straight away, and all it's done on the fly with no heat increase, no particular power increase either. And then you get dual actuator because you've got all this data compressed into a very small space. So getting to the data becomes a lot harder. And this is what we call IOPS per terabyte performance. And customers have upper and lower limits. And if you fall below that limit, then you're not providing the quality of service that customers require. So what we do then, we have the actuator serving all 7 platters in a modern high-capacity hard drive, and they can only read or write one at a time. So that's why we said, well, hey, why don't we split the actuator so that we can now serve 2 demands at the same time? In other words, we've doubled the IOPS performance per terabyte. So suddenly we're looking at a hard drive capacity and hard drive dollars per terabyte performing nearer to an SSD type IOPS performance. And what's driving this is that we know that the world will be producing 175 zettabytes of data by the middle of this decade. So to answer that call, we are producing a whole range of products, high capacity hard drives. What Seagate provides is opportunity to differentiate. It becomes very easy in the IT world to become a Me Too product, isn't it? It looks and feels the same as everyone else. They paint it black or dark grey, put some green on it and call it something new. What Seagate and Symply can offer is a differentiated product, a new user experience. I've discussed already about quality of service. It's about getting the data on and off the hard drive as quickly as possible and in use, which is where it really starts to show its value. Now you can do that expensively with SSD, or you can do it very cost effectively with Mach.2 product. And we think it's a great technology mashup because it really does show how this Mach.2 dual actuator performance can deliver quality of service to end users.